All right.
Maybe you should have stayed right here while you're recording. I know, I said maybe you shouldn't stay here while she's recording.
No, it's fine. I like it. All right, y'all. More right triangle trig, and then this is it for the trig unit. So we're going to use trig ratios to solve real-world problems, okay? So before we can do that, I need to review with you angles of elevation versus angles of depression. Okay, you should have learned this in geometry. In geometry, they would have had two parallel lines cut by a transversal, like that. And you learn which ones are congruent, right? That's a huge part of geometry. Then you would have learned about angles of depression versus angles of elevation and created your right triangle. So angles of depression or elevation always start from a horizontal line. So we call it the line of sight, okay? So the line of sight, you'll see, is coming out straight ahead to create that horizontal line, okay? And then if your eyes have to travel down, that's an angle of depression. Makes sense, right? Angles of depression are never inside the right triangle, ever. And then if you look, an angle of elevation, again, line of sight to the Eiffel Tower will be straight ahead. So if they want to see that person, they would have to look up. Elevation up, depressed down, okay? So let's just label and describe each angle as it relates to the situation shown. So angle 1, 2, 3, and 4. So if you were up here at the top of this hill, here would be your line of sight, right? So if you want to see Miss King, this is Miss King. I don't know where my little thing went. I had her name under it. I don't know what happened. If that's Miss King hiking out west, right, and you want to see her, you have to do what with your eyes? Look down. So angle 1 is an angle of depression. Okay? So then Miss King's right here hiking. This is her line of sight straight ahead, right? If she wants to look back at you, what does her eyes have to do? They got to go up. So angle 2 is an angle of look up, elevation. Good. Okay. And then Miss King's here. Maybe she wants to see that river. What does she have to do with her eyes? Line of sight. She wants to see the river. Look down. So that is an angle of depression. So angle 3 is also an angle of depression. And then if somebody was on a canoe on the river and they wanted to see Miss King, they got to look up, which is an angle of elevation. Okay? So that's important. We'll have some real world problems in just a minute where you'll see how to apply that. Okay? Any questions on angles of depression versus angles of elevation? It's all about that line of sight, okay? So always imagine looking straight ahead and then just consider, are you looking up, which would be elevation, or are you looking down, which would be depression, okay? All right, so in San Francisco, California, it's famous for its super steep streets. So the steepness of a road is often expressed as a % grade. For any of you that have traveled to Meadows of Dan, you've seen that yellow sign probably. If you were a truck driver, you would especially notice it, okay? It says 9% grade, I think, or maybe, yeah, this one's the 17.5 degree angle is messing with my brain. Anyways, it just means how much the road rises for every horizontal distance, okay? So the higher that grade, the steeper the road, all right? So the steepness of the road is often expressed as a % grade. Filbert Street is the steepest street in San Francisco. It has a 31.5% grade. This means the road rises 31.5 feet over a horizontal distance of 100. So let's look at that. So the road is steep, looks like that, yeah? And it says it has a 31.5% grade. This means the road rises. Rises would be this distance. So 31.5 feet over a horizontal distance of 100 feet. So this would be my horizontal. So if you were trying to figure out this angle right here, you would determine using trig the % grade for that angle measure. So to get that 17.5, what did they do? This goes back to yesterday's lesson. To get that 17.5, what did they do? It'd be tangent, yes, because across from the angle that we don't know is opposite, across from the 90, which a horizontal and a vertical always make a 90, right, is hypotenuse. So this side would be adjacent, okay? So if you're looking up, that would be an angle of elevation. Notice this is the horizontal. You look up to the top of the street, so it's an angle of elevation, okay? So that would be tangent. You'd have the inverse tan of 31.5 divided by 100. Questions? So that's how they figured out that angle. Tangent of x equals TOA, which is opposite over adjacent. So to move it, yesterday we talked about this, you just do second, which is inverse, okay? And you would get that 17.5. All right? Questions? So from a point 80 feet from the center of the base of the Eiffel Tower, the angle of elevation of the top of the tower is 85.361 degrees. How tall is the tower? So you have the Eiffel Tower. I can't remember what the top did. The person's standing on it. I'm way off.
I think you're way off.
Don't judge me. What's the top look like?
I don't know.
It's
Is it like a point?
And then it's like a ski line.
Like that?
No, that's a candle.
Man, okay. Well, that's okay. Like that?
Yeah.
And then it has the crisscrosses? Okay, great. Life is good. Okay. So, good job. So, it says from a point 80 feet from the center of the base. So, if you create straight down from the center of the base, you are 80 feet away. Okay? And these pictures are never drawn to scale. I'm just a visual person, so I'm just trying to...
The Eiffel Tower is kind of like a triangle. If you look at the next page, it shows.
Yeah, that's okay. Yeah, thank you. All right, so it says, thank you though, 80 feet from the center of the base of the Eiffel Tower, the angle of elevation. So here's my horizontal. What would you do with your eyes? You would go up, right, to the top of the tower. Okay, so that has an angle of 85.361. How tall is the tower? So are we looking for that diagonal line or that vertical line? Well, the diagonal or vertical? Vertical, there we go. I'm looking at this one, right? So I'm going to call that X, okay? So if it's perfectly at the center, that is a 90-degree angle, right? Think about 85.361. Is your neck, are you going to be leaning, looking way up there? If it's at 85.361 versus 17.5 degrees? Yes. So it's going to be really tall, right? Okay. So let's label our triangle. Across from the angle we call opposite. Across from the 90 is always hypotenuse, which means that 80 feet is adjacent. Okay? And then we have so, ka, toa. I know that because this is a right triangle. Which side has nothing on it? Has nothing on it. I don't care about the diagonal, right? So hypotenuse, I'm going to get rid of so and ka because of that, which means we're using toa, tangent. So the tangent of the angle equals, and that's why we have this ratio, opposite over adjacent, okay? So opposite is X, adjacent is 80. How would you solve that for X? Multiply. So I'm going to multiply by 80. Multiply by 80. I like to put it in the front. If you don't put it in the front, then you got to remember to close the parenthesis because it's the tangent of that angle and then that times 80. So I just like to put it in the front.
Can you explain why you put X as the opposite value again? I missed it.
That's okay. X is the opposite value because we're looking for that vertical distance of how tall the Eiffel Tower is. I'm not worried about if I could fly up there, how far away I am. So that's why I put X at opposite because you always label using the angle, and it's the acute angle. It's not the right angle. Yeah. Okay, everybody, so let's type that in. Remember yesterday I told you make sure your mode, that you're in degree mode. So you hit mode, arrow down and over, hit enter, and then second mode, okay? So 80 times the tangent of 85.361. And then yesterday I also told you round to thousandths, okay? Unless otherwise stated. So 985.911 what? Feet. That's really important. Feet. So it's almost 1,000 feet in the air. Would you agree with that?
Yes.
Yes, I would too. Okay, questions? Let me see what that would be if you had left it in radians. Because sometimes when you get answers, whether you're in pre-calc or next year, if you take stats with me, look at your answer. Because if it doesn't make sense, right, then you need to pump the brakes. Let me just look. What would we get if we had left it in radians? We would have got 47.737. You're 80 feet away. Your neck is craned way back looking up at the top, right, at an angle of 85.361, and you get 47.737. See what I'm saying? That would be a moment where I would say, okay, let me check my calculator, make sure it's in degree mode. And if it is, then maybe I did the wrong trig function or something. Maybe I should have done inverse sine or inverse cosine or something. Okay? Questions for me? All right? To find the height of a pole, a surveyor moves 100 feet away from the base of the pole, and then from an eye level height of 5 feet, she measures the angle of elevation to the top of the pole to be 36 degrees. Find the height of the pole to the nearest foot. I want you to try to draw a diagram representing this. Don't even try to set up the math. I just want to see if you can draw a diagram to represent this. And I'll come around and look, okay? Oh, good, you drew a pole. That's where I start. Then I draw a little person, and I draw some eyeballs, and then I look straight out. Your person's floating there. I like it. That's okay. That's okay. The person's eyeballs are 5 feet away from the pole. I level. Look at me. Okay. I'm the surveyor. Are my eyeballs and they floating up here? And we're 5 feet away. So above the ground, look. My eyeballs are 5 feet. Above the ground. That makes sense to you? Not fussing, trying to think. The hardest part is setting it up.
An X on the pole, lines on the bottom,
Okay.
angle on the end. You like it? Does it look good? Anyway, and the angle is high 36, and then I'm not sure if it's the 580. I don't even know if we need.
I traced it. I couldn't do that. Okay, people. The hardest part sometimes with these is truly setting it up. Once you set it up, you can solve for X, right? It's basic algebra. So, a pole. Okay, there's a pole. To find the height of a pole, a surveyor moves 100 feet away. And then from an eye level, so here's my surveyor, right? With their cute short hair that they just donated. Okay? Okay? And it says from an eye level. We've been talking about that today. Your eyeballs. If you look straight ahead, that's called the line of sight, okay? So from that, if this surveyor looks straight ahead, that's how big? How tall is that? 5 foot. Does that mean the surveyor is only 5 foot tall? No, it means from their eyeballs to the ground, that height is 5 feet. Okay? All right. So 5 feet above the ground, eyeball height. Okay? Then she measures the angle of elevation to the top of the pole. Does that make sense that it's an angle of elevation if from her eyeball she's looking up to the top of the pole? Yeah. So from the eyes to the top of the pole. Sorry, that's not really a straight line. I apologize. But that is 36 degrees. okay? So we're going to assume that pole is perpendicular to the ground, all right? They typically try to put poles in the ground perfectly straight up and down. So that creates a right, what? Triangle. So if her feet are 100 feet away, how far are her eyeballs away from it? 100 foot. So I just created a right triangle. So do I want to know how far her eyes are from the top of the pole? If she could fly up there and measure? No, I want to find how tall the pole is, right? So I'm going to call this right here, what? What do you want to call this piece? X. And we're going to label it, yep, you're right, opposite. The side across from the 90 is always hypotenuse, which means this 100 foot is what? Adjacent. Okay. It's a right triangle, so, ka, toa, right? Which side has nothing on it? We don't care about it. Hypotenuse. So I'm going to get rid of the two that use hypotenuse in their trig ratio. And we're using tangent. So the tangent of the angle. So tangent of 36 degrees equals O over A. O is X, A is 100. How would we solve this for X?
Get rid of the 100.
Get rid of the 100 by multiplying. Good. So 100 times the tangent of 36 equals X. You're welcome. All right, what's X?
72.654.
72.654. So what everybody got? You know the double tilde, the squiggles. The double tilde means approximately. It shows somebody you rounded, right? Is that how tall the pole is?
No.
No. So common mistake is students put the answer right there. They put a box around it. Because you're like, yes, I found it. Well, pump the brakes. Look. Is that the height of the pole? No, that's only part of the pole, right? That's up from eye level, okay? So we have to do what? Add 5. So it's actually 77.654 what? Feet. Really important. Especially if you take physics next year, you're going to she'll emphasize units of measure, okay? Because feet, yards, meters, centimeters, inches, they're all drastically different, okay? So anybody going into engineering, units of measure, super important. Make sure you always include them in your answer, okay? Any questions? So you'll notice a lot of these problems use tangent, and that's because it's real to life. You know, a lot of times we can measure how far away we are, and then we can use the angle to figure out the height, okay? So that's not, oh, Cheryl's obsessed with tangent. No, that's just real world math problems, okay? A lot of them use tangent, okay? All right, I'm going to let you try this one. It has a picture for you. So go ahead and try it. It says, Ayana walks 15 feet from the base of the tree. She measures an angle of elevation from the ground to the nest of 62 degrees. Find how high the nest is above the ground to the nearest foot. Turn and talk about it once you have it.
my eraser? Hold on, let me write my
It's homemade.
little eraser. Wait.
Ready?
There.
You do good.
Wait, no.
So then you put this in here, the eggs.
How do you even do
You made it anything? I want to finish. This is come on.
Yeah.
I said we switch pencils for a little bit, bro. You guys, there's no reason to take it.
That's so much work.
Keep it on.
Hidden eraser.
I don't
I only use fat
Where is
pencils.
it?
You have a fat pen.
Zip.
Alright, you got it? Everybody got it? Okay, let's see. It'll work until that point. Okay, you definitely need your calculator tomorrow before the quiz. Okay. Number 6. Can't ask any more essays. Okay, go ahead.
So I looked at it and I labeled it.
Okay, you looked at it, you labeled it. Go for it.
The tree with the opposite
Okay,
and 15-foot being the adjacent.
okay,
And then I went over to the left and wrote the tangent of 62 degrees equals x over 15. And then I multiplied by 15 on both sides. So 15 tangent of 62 degrees equals x. Put it in the calculator and got 28.211 feet.
you all agree?
Yes.
Everybody agrees? Okay, good. Way to include those units of measure. Good job. Any questions? No? Pretty straightforward, right? Okay. The angle of elevation to the top of a volcano crater is 47 degrees. And then it says from a point that's 900 meters farther away, the angle of elevation is 35 degrees. And I don't know about you, I'm such a visual person that I have to like sometimes envision myself in the scenario, right? So it's, okay, way over there's a volcano. To see the crater that's at the top, I look, what, line of sight, I'm going to look up. And it says it's 47 degrees. Then 900 meters farther away, I'm going to back up, right? So as I back up, if I still have that line of sight up to the top, look what's happening to my arm as I back up, right? It's going down. So it makes sense, doesn't it? Hey, you don't have to not. Oh. Hey, welcome. Yay. Okay, well, I'm glad that didn't break. Okay, so it makes sense that the angle of elevation is smaller the farther away you are. It's kind of like a while ago with the Eiffel Tower problem where we're craning our neck up at 85 degrees, right, to see it, okay? But realize, did I tell you how far away you were? No. So, just imagine you're here, right? If you look straight ahead, there's line of sight, right? Okay? And it says to the top of the crater, it has an elevation of 47 degrees. We don't know how far away that is, do we? No. So you'll notice, I'm going to put an X right there, okay? Then it says you move 900 meters further away. So I'm going to back up 900 meters. Does that mean that's how far away from the canyon I am? No. Then it says the angle of elevation to the top is now 35 degrees. Okay. How high is the crater? Ooh. I already got an X, so I guess I'll call it. Should I call it X? No. You don't know that this height this height right here is the same as this horizontal length. So you can't call it X. So you might as well call it Y. Okay. So how many variables is that? 2. When you have 2 variables, you need at least 2 equations. Okay. We've worked on that this year. So, you know, I like to have that volcano crater, the picture to help, but then I like to simplify my life. So I'm going to draw that first one pretty small. I know that's 47 degrees. I know this is X. I know this is Y, right? Then I'm going to draw once I back up and the angle became 35 degrees. Now, what do I put on this horizontal distance? Do I put 900 meters?
900 plus X.
I put 900 plus X. Good job. Yeah, you don't know how far back you were originally. You just knew the angle of elevation to the top. And then you went 900 meters further away. So, yeah, you got to add the 2 together, okay? And then this is still Y. Okay. What do you think? Mull it over for a minute. Mull it over for a minute. I'm going to give you a little bit of time.
Okay, I'm
Oh yeah, sorry. Cause in right now. And then this one's elevation.
Okay, go ahead and discuss it with the person beside you. See if you can set up your trig ratios for those 2 triangles. Just set up your trig. Set up your trig, okay?
So wasn't it moved? I just love like to see what the other angles would be, but it's even.
This yes for 5.9 and 5.10
Okay.
today.
Well, I haven't done this one yet because we're working on it, but I already did 4.9.
Because I tried to watch all of them yesterday so I can get like my memory refreshed. But
We wasn't there. Yeah, I did it this morning. I
and
apologize.
and the part 2 of 5.8 is like
It wasn't there either because yesterday I finished it. I prepared it again in class. It's there now. I did this morning. All right, so all I asked was that you try to set up your trig ratios, right? You have 2 right triangles, so we can set up the trig. Let's see, who's number 15? Okay. What do you think on that first one, the one to the left right there with the 47 degrees? Can you set up a trig ratio?
I did tangent 47 degrees is equal to y over x.
You said the tangent of 47 degrees is equal to y over x. Because this would be opposite. This would be hypotenuse. This would be adjacent. And if we look SOHCAHTOA, we have nothing on hypotenuse. Okay, do y'all agree with that? All right. Number 18. Number 18. What do you think on the one on the right? Not asking you to solve, just asking you to set up the trig. Tangent of 35 degrees.
Is equal to x over 900 plus x. And y over
Good.
900.
Y over 900 plus x. Okay. So now I have how many equations? 2. I have 2 equations and 2 variables, yes? So let's look to see what's similar. So in both equations, I have a y. And in both equations, I have an x. Oh. Not sure why it erased. Okay, try again. There we go. So you should have learned in Algebra 1, Geometry Algebra 2, that you can use the transitive property to cut out the middleman, right? So you learned associative, commutative, all those things. Yeah, you don't remember them, but you do things like it. You just don't realize it, okay? So like you move multiplication around, that's the commutative property. But this one's really important because look, can you solve for y? Can you solve this one for y? Can I solve that for y? Yes, the first one, the one on the left. Yes, how do I solve that for y? Multiply by x. So I get x times the tangent of 47 degrees, which, is that a number? Yeah, it's a nasty decimal, so I'm going to leave it alone, okay? But yes, it's a number. Equals y, okay? Can you solve this other one for y? Can you solve the one on the right for y? Yeah. Y equals what? What would I do to solve this for y? I would multiply by 900 plus x. You'll notice I'm putting them in grouping symbols. Why am I doing that? Because they're being added, right? So you can't split them up. You got to make sure you keep it together, okay? Anytime you see a plus or a minus, you got to keep them together, okay? The reason why I rewrote it with the y in the front is because, look, here's my x on both, but here's my y. If they both equal y, what does that mean about them? Say again? They equal each other. That's called the transitive property, right? I used to, when I taught, I said, cut out the middleman, right? If you want to make more profit, you just sell directly to somebody. You're going to get that profit versus if you sell to somebody, then they mark it up so that they can make a profit, and then they sell to the next person, right? So cut out the middleman, okay? That's what we're doing. We're going to get rid of that. Because if they're equal to y, that means they have to equal one another. Okay? Well, that's good. Tangent of 35 degrees. Tangent of 47 degrees. I'm going to pause a minute, and now that I've got it down to 1, I'm going to pause again, let you try it, okay? It's okay if you don't exactly know what to do. I hope you can move forward a little bit. What are you trying to solve for? Yeah, look, y'all, what are you trying to solve this for? X. Okay, so think about how you solve for x. Normally we try to get it all on one side, right? And also keep in mind, tangent of 47 is a number. Okay, it's a nasty decimal, but it's a number. And also tangent of 35 is also a number. Okay, so keep that in mind. But, and just see if you can do it. Yes. Sure.
Your calculator history is really bugging me, Miss Harold.
My history?
You never clear anything out. There's so much stuff.
Sorry. Well, I already said if somebody borrowed it for a quiz or a test, but otherwise, no, I don't. Okay, take one more minute. One more minute.
Did you say don't plug in the, like, tangent?
I don't convert until the very last. It's called round off, build up. If you round it early in the problem, it can build up until you finally get to the final answer and really significantly change it. So I don't plug it in the calculator until I finally have isolated X.
Well,
If
that's
that
what
makes
it is, like when you go.
I only told you tangent of 35 and tangent of 47 are both numbers, try to help you figure out how to solve it. Right? So, for example, what I mean by that is like, if this was, hey, just look real fast. If this was 3 times x, right, equals 900 plus x times 4. I'm totally making up numbers, right? But the reason I'm trying to do that is because this is a number, so I made up a number. And this is a number, so I made up a number, right? But when your brain sees this, you probably go, oh, I see what I should do. How do I get those x's together? Y'all, I learned to do this in college because you get these complex math problems and you look at it and go, I'm stuck, right? So you can help yourself. This is called prior knowledge. I have prior knowledge of problems like this. So I just made it up, right? But I see that I can distribute, right? Which would then give me 3x equals, I don't care about the first piece, plus 4x, right? And then you would try to get it to the same side, right? Okay, so let's use that knowledge. Let's use that knowledge. Really? It was not filling it. Okay, let's use that to try to get all of this together. So you saw, what did I do first? I distributed. Yep, so I'm going to distribute this and distribute this, and I get x times the tangent of 47 equals 900 times the tangent of 35, right? That's all a number. It's a nasty decimal, but leave it, okay? Plus x times the tangent of 35. So do you see that I distributed tangent of 35 to both pieces? Okay, and now can I get these on the same side? Yes, how would you do that? What's the opposite of plus x tan 35? Subtract. So I have x times the tangent of 47 minus x times the tangent of 35 equals 900 times the tangent of 35. So unlike my simplified one where I had 3x minus 4x, which would be negative x, I can't do that, right? So instead, what do you notice about that front part? What do you notice? They both have an x. So you can factor it out, and you're left with the tangent of 47 minus the tangent of 35. This is going to serve you well in the next unit if you can recognize that you can factor it out, okay? We're getting ready to move into the exponential unit. We'll have to do things like this. So I factored out the GCF. That's what that's called, okay? So I factored out the GCF. And I'm left with tangent of 47, which is a nasty decimal, minus the tangent of 35, which is another nasty decimal, okay? So now you have x times those things. So how can I get x by itself?
Once you subtract it, distribute it back into it. Or what you ask?
How can I get that away from the x? Divide. So x equals 900 times the tangent of 35 divided by the tangent of 47 minus the tangent of 35. So I solved for x, right? What was I looking for, though? I was looking for, it says, how high is the crater? How high is the crater? Was x the height of the crater? No, it was y, right? So if you look up here, you've solved for y, haven't you? You have how many equations? 2. So you can choose. Once you know one variable, you can choose whichever equation. You plug in x, you've got y. So look, I'm going to choose this first equation. which said y equals x times the tangent of 47. Why do you think I chose that one instead of the second one? It has extra details like that 900 plus x times tangent of 35. Yeah. But you can choose whichever one you want because now that you know x, you can just plug that straight in. Now, be careful when you type it in your calculator because when you hit the tangent button, you should notice it opens a what? A parenthesis, okay? If you do not close it, it's going to take the tangent of whatever follows it, okay? So when you put this in your calculator, you need to have 900 times the tangent of 35. It opens a parenthesis, so you need to close that one, okay? That is a fraction, so I need to make sure it divides by this one minus this one. So I tell students, just do this in pieces, right? Do 900 times tangent of 35, hit enter. Now hit divide by and put parentheses and then put tangent of 47, close those, minus tangent of 35, close those, and then close the overall ones that you created, okay? And you get a number. I don't care about that number. That's how far away you were originally. I don't care about that. What I want is plug that in right here, what you just got. Don't round it, just plug it straight in, and then hit times tangent of 47. And you get how far? How far away are you?
I can't see that.
How far away are you from the crater? Or how tall is the crater, rather? How tall is the crater?
It was well, the second one. There was an error, but
What?
this one was 180.
Round. Yep. So 1815, right?
Yeah, 860.
860. That's what I got. And feet, meters, miles. What are you doing?
That was feet. Is it feet?
Is it feet?
Oh, we choose feet.
No, look. What units of measure did the problem start
Oh,
with?
it was in meters.
It was in meters. So the height is actually 1,815.860 meters. So this is how tall, which is what I was looking for. Sometimes I give you two-part problems. I may say, how far away are you from it? So you would find that initial distance and then add 900. That's how far away you are at the end. And then you can use that number to find how tall the crater is. Yes?
Would you accept, or like, are we allowed to, so it's easier to put in the calculator, like find
I'll
for
put that
x
same
the
thing.
number, like first?
Yeah, that's what I'm
and then-
saying. Just don't round it.
Oh, okay.
That's called round off build up. And in stats,
And
it's
then it
more of a
gives it
thing.
wrong.
Yeah, by the time, so let's say you round here, then you plug that in, then you round that number, then you plug that in, then you round that number. By the time you finally get to the answer, it can be off by quite a bit.
All right,
Yeah.
so well for this one, because I don't know how it would be, but before you said not to round off, I had rounded off.
Yeah.
And the number was only different with this one by a little bit, so it was kind of wrong.
A little bit. You know, if it's I'm not going to count it wrong, but if it's a multiple choice test or quiz
Oh,
and
if
two of the
multiple choice,
answers
yeah.
are super close, which one is it? You know what I mean?
Yeah, but if it was like an FRQ, would you? Because it's like off by 0.2.
Yeah, if it's an FRQ, I would not take, as long as you show all your work. If there's no work for me to grade, I can't follow your thought process. Okay, are you good? Everybody good? All right. So I like this because it just helped review angles of elevation versus angles of depression. You'll notice right here, it says, as seen in the diagram above, the dark black horizontal line is parallel to the side CA of a triangle ABC. That's where that geometry piece came in. You would create parallel lines and then do alternate interior. Did everybody just hear me? So we didn't have an example like that above, so I'm going to show you. Everybody pay attention. When you have parallel lines, which horizontal lines of sight are parallel, okay? Then if they're cut by a transversal, which is what that's called, if this is X right here, then you have alternate interior. This is also X. You should have learned that in geometry. You had alternate interior, alternate exterior, same side interior, which adds up to equal 180, and corresponding, right?
I use it on this problem to find out it was equal.
Nice. Yeah, you can absolutely use that stuff. I mean, that's the beautiful thing. If you can remember that stuff, it helps you. So anytime you have an angle of depression, it's actually not inside the triangle. You have to move it, okay? So if this is X, then this would actually also be X, okay? The issue I have seen teaching this class is people with the angle of elevation, they try to put it in the triangle. and then they label their triangle wrong, and it just messes everything up, okay? So make sure it's always with the line of sight and then down, so it's actually outside the triangle. Any questions for me? No? Everybody good? Okay, well, try your practice problems then.